On. All right, we're live. Hey. All right, everybody. Hey, how are you? Welcome to Season 2, Episode 2 on climate science. I'm joined here by my trusty companion, Nasi Enceno Velasquez.
Howdy.
We're going to call you Nate because that's what's hosted by on the screen.
That's what the slide says.
That's what the slide says, so I'm guessing that's the truth. But, all right, so basically what tonight's episode is going to be a little different from what we did previously is that we're not going to talk about the outcomes of what climate science actually dictates or what the explanation is, such as that temperatures are increasing, that the world is getting hotter, that the globe is getting warmer, climate change is actually a real thing, yada, yada, so on and so forth. We're actually going to talk about the models into which those conclusions are drawn upon from. But I want to talk about a few other things first.
Well, sure. There's a bunch of things going on, man.
So, the fight, that was a big thing.
Yep.
I think I thought he did a lot better than what I'd anticipated.
I was pleasantly surprised, I got to say. I was expecting it to be 12 rounds of boring-ass bullshit, just Mayweather basically slipping and rolling, right? I expected Conor to do early in the first couple rounds, and he did. He did much better than people thought he would, I think. I think everyone was kind of surprised. But, he's going against arguably the best boxer of all time.
Literally
50-0.
51-0.
Oh, that's
so
terrible.
my whole thing is
That's
that
terrible.
he did beat his wife, and I got called out like that I'm a social justice warrior or whatever on the Facebooks and stuff. But honestly, I'm of the belief that if I can get my federal funding taken away for a felony charge such as that, to do cancer research, it doesn't matter how great of a researcher I am, I'm still getting my funding taken away.
Sure.
So I just think that there's a double standard in our society that allows that athletes can, such as Greg Hardy, Mayweather, that can actually go out and beat their wives, and then all of a sudden there's no consequences. I'm going to make hundreds of millions of dollars, millions of dollars, hundreds of thousands, whatever the price tag is. It's just that there's such a horrible double standard. And I just wanted to
Floyd's going to
that.
clear north of $300 million for this fight. That's without advertising sponsorship. So he's doing pretty well. I agree with everything you're saying. It's very difficult from a societal standpoint. You have someone who's trained as a boxer, someone who knows what he's doing. And he's literally using his training on someone who has no training at all, which is a terrible situation. But there are no rules against it. Boxing is not a league, not an associated group of independent promotions.
Another reason why I think boxing is terrible. It's honestly, boxing is one of the most boring sports that I have ever.
The undercard was really boring, except for the second fight. I forgot who was fighting, but the second fight wasn't bad because that's the one that ended in a finish. I think it was like the 6th or the 7th round.
Yeah,
but I was just happy because it ended.
Yeah, it's over. It's done.
I'm coming from an MMA background, so every time I see them just with hands, I'm like, oh man, just the head kick right there,
boom,
double leg right there.
At one point, they were in the clinch.
Conor was always grabbing his hips.
He was right up. Well, they were face on face, and he was right about. I saw his leg go up a little bit.
If you saw every time they clinched, Conor was always digging for the underhooks. Yeah. He would always sneak his hand underneath the armpit, and then he's like, oh wait, can't do anything. I think he was waiting for more of a break in the clinch.
Boxing is terrible.
Boxing is terrible.
Boxing is the most boring martial arts sport there is. I'm sorry. I think I'd rather watch two fat guys wrestle each other than watch boxing.
It's pretty boring, but I mean, it's still the number one sport in terms of pay-per-view. Beats out UFC 100% of the time.
Fair.
You got Triple G and Canelo's coming up in September. That's going to do really well. That'll be a good fight because both of those guys have good styles. But man, it was a good fight. I'm not surprised. I'm a little surprised that I think there's a lot of people that are taking Conor's. Don't get me wrong, he did very well.
Yeah.
But Floyd also kind of let him. Floyd threw 4 punches in the first round. Floyd didn't. He knew Conor gets tired.
I saw a meme that was them hugging the day after.
Oh, and they're just floating.
It's
money?
When you finessed enough that you just took the world for $400, $500 million.
Oh, yeah, 100%.
Just because you and your boy were like,
yeah,
God, these guys.
I mean, look, there was probably some shenanigans going on. But yeah, I mean, look, it was a good fight. I was pleasantly surprised. It'll probably be the last boxing match I watch until Canelo Triple G, and I'm not paying for that one. I'm probably just going to
stream it live on people. I like how Facebook now you can live stream everything and just see it for free.
So about that, that's how you get caught.
But another thing that's kind of related to what we're going to be talking about tonight is Hurricane Harvey.
Mm-hmm.
You know, a lot of people were like,
Dave, can I stop you real quick? Yeah. I love how, and there's a bunch of memes on this, so I'm sure you saw them. I'm pretty sure you shared one of them. I love how we love scientists when they predict weather and things like this, natural disasters.
Or like the eclipse.
Prepare for the hurricane. Prepare for the eclipse. Don't look at the eclipse. You're going to burn your eyes. Right? Everyone pretty much universally accepts the science because they see it.
Yeah.
And then when it comes to things like climate change and Antarctica literally turning green and literally, I don't know how big that ice shelf is, the state of Delaware just floating around somewhere.
Literally the size of Delaware or double the size of Rhode Island.
Right, yeah.
So it's just floating there.
Just floating.
Like, hey, I'm a big ice block. I was attached to that glacier.
But that's all fake news. That's all fake news. Yeah.
Totally fake
news.
news.
No, I'm sorry. We continue. I just wanted to make that point.
Like everybody says, well, I just heard the statistic that the level of the river around Houston, forgive me, I forgot the name of the river, but instead of the last peak that it was ever at was 54.5 feet. Mm-hmm. Now it's at 59 feet.
54?
54, 59. So that's the maximum. Yeah, so it's from the hurricane. So, a lot of people go, blah, 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 it's just a natural disaster. These storms happen all the time. And I'll say yes, I can concede that remark. However, the whole thing about it is that, when you have a 1.5 degrees Celsius increase in air temperature, you have 50% increase in the amount of moisture or water vapor that can actually be held by the atmosphere. So it allows the water to be up there in the clouds and then drop a lot quicker at a lot higher rate. Like this summer, and I mentioned this and I commented on this, and I know it's anecdotal evidence, so it's only colloquial or it's very local. When you see rainstorms nowadays, is there ever one that you ever see where it's just a little trickle of water that goes to a little heavier and then back down? It's torrential downpours. Mm-hmm. When there's a storm, it's a torrential downpour.
At least in Philly, it's been torrential downpouring this summer.
All summer. Every single storm. It's like somebody took a bucket and just dumped all the water out from a cloud.
Yeah.
So these things all together really kind of give me a little bit more backing in terms of like saying, yeah, because of climate change, these storms are going to get more severe. Mm-hmm. And predicated upon, the science that we're going to talk about, with some of the parameters that these climate models actually look at, is like, hey, this is why we're saying that there's going to be some disasters. There's going to be economic downturns. There's going to be economic impact predicated upon what we're going to discuss tonight.
Right. I mean, so basically, it's going to increase the frequency of high hurricanes, tropical storms, whatever you would categorize them, due to just the nature of how they form, right? And because of that, you're going to have more disasters, which means there's going to be more economic downturn because of that, which, again, like you can only look at the city of Houston and what they're dealing with today, right? Exactly. I'm sure there's no businesses that are open, right? I mean, not to mention the amount of money that you have to spend into disaster recovery, and then the amount of people that can't work, the amount of people that lose their jobs, housing, all those things.
And as much as I hate insurance companies, is that they have to take that risk, and then what are they going to do? They're going to put that onto the bigger population of Texas. So people in Western Texas, Dallas, that aren't really going to be affected by the storm, their premiums might go up. Their insurance costs will go up. So it's not just necessarily this cattle channeled type of view to this, is that there will be problems that will arise from climate change that you don't necessarily see unless you take the bigger picture as a whole. So let's dive into it, and I have a nice little slide behind us that, kind of defines the difference between climate and weather. And, I kind of want to show this to the senator that was on the floor of the House, or floor of the Senate, holding a big snowball going, oh, well, if I have a snowball in my hand, climate change isn't real. Just because you have a snowball in your hand from one weather storm does not mean that climate change over.
This is?
I forgot his name. Oh, my goodness.
A nonsensical argument.
It's...
Now, Dave, that's like saying that because it snowed in King's Landing that the White Walkers are never going to make it down there. They'll make it down there. It's just going to be a matter of time, right?
Yeah, it was an Oklahoma congressman.
Okay.
Inhofe.
Okay.
James Inhofe.
Well, we'll have to
strongly denies climate change exists and brought a large snowball to the Senate floor. Just because you have a snowball in your hand does not mean that climate change isn't true, isn't real. It's just a misrepresentation of the facts. And I just read an interesting article on BBC News, and I didn't reference this in our presentation tonight, but it's about tetraethyl petrol or tetraethyl gasoline. In 1924, 1925, 1928, there were several conferences that literally a woman, Dr. Hamilton, literally said petrol with lead will cause increase in crime, will cause all these negative outcomes in violence, in developmental biology, in terms of like your children being exposed to lead. Everybody now knows that any degree of lead is horrible for you.
So, pretty bad.
Like I'm not going to go up to lead paint and just go, no, no, that's stupid. So we're at that same stage with climate change right now because people want to make a false straw man argument about it, basically saying, oh, well, 3% of climate change scientists say that, it's not real. So it's not real.
Yeah.
That's
Well, Dave, you know what we really need to do? We need to have an A team. We need to have a B team. We need to have scientists on both sides come together and debate it, because that's how science is really broken out, right? It's not, what I would love to see is a room full of all the scientists, just like on the side of reason that, practice what they preach, versus maybe like the 5 guys that probably
paid off by
not only are they paid off, but you got to question someone's degree and their actual understanding of what they're talking about.
Internal documents for ExxonMobil has actually come out.
I saw that,
saying that they covered up climate
since the 70s, right?
Yes.
Yeah.
They knew that the impact of climate change was going to happen because of CO2 back in the 70s.
Well, dude, it's just like, cigarette companies back in the 40s and 50s when they had to keep changing their advertising every year.
Oh, the doctor smokes
Doctor
Camel.
smokes it? This one's for me.
Doctor smokes Camel, so this is the best and healthiest one. I get that, but all right, so let's define climate. Climate is defined as the various atmospheric conditions, the atmosphere, the sky around you, the entire biosphere, basically, which include rainfall, temperature, wind, humidity, other meteorological elements, etc., in a region over a long period of time. So what we're going to discuss tonight is that when climate scientists make models, they section out the globe into small little squares that go from the surface all the way up to the very, very tippy tops of the stratosphere. And predicated upon these variables that we just listed here, they put in formulas that we'll show in a little bit, saying, okay, predicated upon these parameters, over this course of time, if you add this much CO2, it changes the wind pattern like this, or it changes the temperature, it changes the amount, like I said, the amount of water or water vapor that's be able to held in the atmosphere for a longer period of time, and it can dump a lot quicker. So you're going to have torrential downpours, you're going to have mudslides, you're going to have different types of flooding that you're not experiencing right now, and all these records will start to be broken. Just like in the past 17 years, 14 out of the 2,000 years, 2000, second millennium, whatever 2000 millennium you want to call it, has been the hottest years on record. But some people will go, oh, well, 1933 was the hottest year on record. No, that's not true. You're actually only using like very manipulated data. So I can make my data say anything that I want as a scientist because I know how to manipulate statistical models. And I'm not saying that because climate change scientists do that. I'm saying that because climate change deniers 100% of the time
I just love the look of frustration that's on your face right now because I think it's pretty obvious.
It's just they cherry pick the data that they want to represent. Like when Breitbart, for instance, remember when that meteorologist from the Weather Channel got really upset with Breitbart about saying, oh, well, she said that climate change isn't real because, the temperatures dropped over this landmass. They were talking about one continent or 2 continents and how the land temperature actually dropped when, I don't know about you, but 2/3 of the world is covered by Brian Dawkins and water. So, gotta lighten the mood up just a little bit.
I love it. I miss him.
Yeah, me too. He was such a good dude. I liked him when he was on, I think he was on
Denver.
Sports.
Yeah, he was in Denver. I mean, look, he's a great guy, but he needs to play again.
And a lot of people will point to old models, like 1960s, 1970s, when we didn't have the computing power, and it was a bunch of people in a room, literally doing math by their hand. You're going to have some anomalies.
Yeah, well, not only that, but just the computing, like your phone in your hand right now is stronger than any desktop, any laptop computer from 10 years ago.
Oh,
like there's an astronomical more amount of
this computing power is more than what got us to the moon.
Oh yeah, 100%. Yeah.
But wait, wait. We didn't get to the moon.
Well, look, when they shot that fake film in the Hollywood studios, your phone's stronger than that, pretty much.
I know. Yeah. And a lot of the things is that we haven't been taking record of CO2 in the atmosphere until 1968 or 1972. Somewhere around the 1970 mark is when we actually started taking atmospheric levels and actually.
Was that just due because they couldn't measure it?
We have better technology to measure it. So predicated beforehand, pre-industrial era, in 1970, we already had 10% more CO2 in the atmosphere than we did in, like, say, 1705 or 1750, before the Industrial Revolution happened.
All that steam, all that coal power.
All that coal,
baby.
Clean coal, which is, we should have another episode on that.
We should do clean coal again. We should
it's
bring it
literally
back.
like the biggest lie that's ever been told. There's actually a plant, I forget, in Louisiana, Mississippi, or Alabama, one of those three states that tried to promote clean coal and was a clean coal facility. They're switching to natural gas because they can't make clean coal. So far be it from me to stop them. But, you know, as I was saying, weather is defined as the atmosphere at a given time and place with respect to variables such as wind, moisture, storms, snow, temperature, rain, barometric pressure, basically everything that you see on the Weather Channel when there's a big storm coming. You know, like, okay, the pressure's dropping, this is happening, this is what we predict.
Sure.
And we get it wrong, obviously.
Yeah, well, I think that's why a lot of the, whether it's climate science or just, you know, flat earthers or whatever it is, they find, you know, a couple of things that are wrong, like, oh, it's going to rain today, it doesn't rain. Flat Earth! That proves it. Did you see the theory that flat earthers had about the eclipse? Like, no, this proves it.
No, I didn't.
I'll have to send it to you. It's a great read. It's a great read.
I wish we should have saved that episode until after the eclipse, but
we'll circle back.
Yeah, we will. We'll come back to it. But I really find that a lot of people just look at climate models and go, okay, there's a hole in this one, so that's why it's all wrong. But what a lot of, like, the NOAA, North Oceanic, whatever, the government's weather people, NOAA, I don't know what the NOAA actually stands for. I should look that up. Sorry for me. But they basically look at everything. They look at not just one model, not just two models, not just three models, but I'm going to flash ahead real quick. Here's a list. There's 40 different models behind us that are all layered upon one another. And we're going to get into, like, the types of models and their shortcomings and why a lot of people go, oh, you know, well, they see, I think it's actually the CCSM4 is the one. Oh, actually, the CNRM, these two right here. And they go, oh, well, there's a hole in this one because it doesn't take into account variables such as cloud cover and different things like that. We don't understand all aspects to weather and climate as of yet because we're a small species, or it's an over many generational type of event where we do need more data. And there are limitations to climate models, and I will fully admit that. But it doesn't make all climate models nonsensical to the point where, you know, if you layer 40 things on top of each other, say it's whatever, like coffee filters. Yep. You're gonna eventually get to the point where you're not gonna get any water through it if you pour just a cup of water through, because it's gonna catch all the water. You know, it's like those Pampers commercials where you see, like, oh, my baby has the super duper dry because it has 1930 layers or whatever. Yeah. We're gonna catch all the liquid. That's kind of like what these models are stratified as. It's like, okay, there's a hole in this one, but we use this one to counter that.
Yeah,
and then backup
data.
And it's literally just layering the data on top of each other to give an overall picture.
Of course.
And it's not necessarily like we talked right before about statistical relevance. These climate models are put through supercomputers, which also a limitation. It's because we don't have super duper computers. We have supercomputers.
Sure.
And I'm not a computer scientist, so I'm not even going to try to delve into that. But it's like basically taking my computer from 10 years ago and running all these models, or compared to my computer now and running all these models again. Yeah. I'm like, okay, so it's a little bit better. It's quicker. We're going to get a better analysis to the point where it's like, oh, right here, we made a mistake 10 years ago. So it's not going to be 5 degrees Celsius, it's 4.7.
Right, and that comes with time. You know, you have to just put in the time, do the data, do the research. The technology gets better over time. Again, computers are better, stronger.
And on top of that, the observations that we have between generations. We've only been really recording, like, to the level that we expect now since the 70s. Like, where we're literally recording all the different parameters. And the parameters are right behind us. Aerosols, dynamic vegetation, meaning, do trees grow? Do trees constrict? Do we have a lot of farmland? Do we have turnover in some areas? Is it land surface? Basically with sea ice. Do we have sea ice that expands or contracts over time? And as we get a little bit more in tune with how it contracts and how it, grows, whatever, we can get a better picture of the overall dynamics. And it's not necessarily that, we understand every single aspect to it. It's like the carbon, nitrogen, oxygen cycle. Mm-hmm. We didn't even know about those things until 100 years ago. And to say that we know every single little thing about them it's insane.
Yeah.
So,
well, I mean, look, the whole point of science and research is because you know that you don't know all the answers. Bingo. You know that you're literally trying to prove yourself wrong. You know that in a year, your published paper, which everyone loved, someone might be able to poke a hole or two in it, right? But that doesn't throw out the 90% of the rest of the work that you did, right? Like maybe you have to throw away one paper, right? It's like when you were in school, right? Cite all your sources. Maybe there's some bullshit that kind of snuck through. They're like, all right, look, we're going to have to remove this section, but the rest of this is still sounding really great.
And even like on top of that, it goes to the point that like the vast majority of the field goes, hey, it's between 1 degree and 4 degrees or 5 degrees. There's no below that. Yeah. There's no contesting the fact that climate change is happening. It's the fact that, okay, so one model says 5 degrees, it's one model says, right. Yeah, and at which, is it 2050? Is it 2100? At what point is literally, excuse my French, shit gonna hit the fan?
Yeah.
And, it's these things over a long period of time that really starts to, really bring a hole into it. So, these parameters are just some of the small parameters that people have to take into consideration when devising formulas, mathematical formulas, because, these are some of the fundamental equations. Like when I look at the conservation of momentum, energy, mass, conservation of H2O, and equation of state, Nate, I'm not a physicist.
I don't know.
I am not a physicist
Couldn't
at
tell
all.
you either.
I could probably derive those formulas at some point. Give me about 3 days, 4 days, with a lot of freaking caffeine. Yeah. Maybe like Red Bull straight to the face, like shotgunning it. But, I trust the expertise of the field. Mm-hmm. I'm not going to go call into question like, the derivative of P over T does not equal volume vector, the volume in which the vector changes, over the change of blah, blah, blah.
Right. Like you wouldn't walk into one of my meetings and say, Nate, we got to put all our ads on Facebook. All the ads on Facebook.
Oh, no.
Sorry. We'll make it work. We'll make it work with or without the projector. But yeah, you wouldn't go into someone else's field and question everything that they did when you don't have a background in it at all. I'm not going to
say, hey, Nate, because not 5 people didn't click on this ad today, you're wrong about the overall length of your marketing campaign.
Yeah. It's the same thing. It's the same principle.
But a lot of people do that because they can go, Science Direct or, Phys, like phys.org says that the parameters for climate models are bullshit.
Well, you do have a lot of people not only distributing just the wrong information, but they make it seem really right because they get a nice fancy YouTube video, they get a nice projector, right? They get some cool cutaways and some great sound effects. We don't need that.
So we may have a camera and a microphone now, but we're just trying to improve our
baby steps. Baby steps.
I know what I mean. You know what I mean. But, look at the grid point model thing. It's basically saying that you take every single point of the Earth, and some models are bigger, some models are smaller, and they basically do all these different parameters. And they try to make a mathematical formula predicated upon these different areas. So one area is linked to the other area. So the weather pattern here, or the climate pattern here, over 100 years, does affect the next grid, and the next grid, and the next grid. There are shortcomings to that, because it's like saying, I can look at you, Nate, and say because of the skin block here, I can determine that your knee is going to be blown out in a year.
Ooh, don't tell me that.
It's not really how any of that works, but a lot of people make it seem that is, that's how it works. You can't predict what's going to happen in Scandinavia. It's going to happen in Africa. Mm-hmm. But it's all interconnected, and that's kind of the reason why, to a certain extent, it's not going to really be the best model, but that's just a shortcoming of the model, not necessarily that it's throw the model out.
I don't know where this fits in terms of what we're going to cover, but I've always been very curious about farmers' almanacs and how they're actually pretty spot on,
And that's
not
just
to mention
basically
that, they did all of that without data or science. Like
farmers are probably the smartest group of people in the entire world.
I mean, I believe it. You have to know a lot about your climate and your environment and all the different things that are changing on an ongoing basis.
Your plants.
Yeah.
And the thing about that is that those predicated upon older compilations of knowledge that are thousands of years old. You know, so in America, it's a little different because we've only been here for 400 years, but it's predicated upon, okay, if I see this in the early spring, I will most likely see this in the late fall.
Sure.
If I see this here, I'll see this here. And that's a lot of correlation. It doesn't necessarily mean that it's causation, but it does give you a general idea of...
So just like Punxsutawney Phil?
Yeah, kind of, to a certain extent, but...
We got to phase that out. We got to phase out Groundhog's Day.
So I'm going to keep talking while I try to get the display back on. I have no idea why it keeps shutting off on us all the time, but... It is what it is.
We just need to shake the mouse around every once in a while.
I don't think it. I think it's that I have to actually jump up on the table. But hopefully people can still hear me. And literally, what we're going to talk about next is, you know, oh, there you go.
I think you got it.
I hope I didn't break it.
I hope you didn't break it either.
All right. Well, we'll see. Worst comes to worst, we continue on without the presentation. However.
Everything does look better with pictures. People do love pictures.
I like pictures.
Some people are visual learners. Some people are audio learners.
I am definitely not an auditory learner.
No,
you could talk at me for
I'm
an
a visual,
hour,
and I'm whatever you would call it when you have to do things. Kinesthetic?
I think so. That's muscle memory. But predicated upon what I can do is I can read something. It's in there.
Sure. Done.
But auditory, I could sit in a class for 2 hours and somebody talks at me. Don't know anything. But all right, so a couple of the things about uncertainty, and we talked about this a little bit. Parametric uncertainty, which is uncertainty in climate models, is doubt about the correct value of a specific variable, such as how much rain fell in a certain area in a given in a place in a given year. This type of uncertainty stems from scarcity of data, which is especially pronounced for time periods before reliable modern measurements, like how we said that we didn't measure CO2 before 1970. And for regions in the southern hemisphere where there are fewer observational stations because it's a poorer area.
Back.
Oh, hey, we're back. Yay! Right. Structural uncertainty is doubt about the relationship between two or more variables. For instance, the way that clouds influence and are influenced by temperature change, for example, is not yet completely understood. This lack of understanding about how multiple processes relate to each other can lead to inaccuracies. I want to go back to this real fast, the parameters of climate change. Lead to inaccuracies in the model. Despite these persistent uncertainties, climate models have grown progressively more accurate as more data are collected and as our understanding of processes grow. The most advanced climate models are currently able to give us a relatively rich, if a little incomplete, picture of how Earth's climate will change as a result of human greenhouse gas emissions.
So and I'm sure the most important part here, and I'm sure that with another year and another year and another year, we're going to get more accurate with more information, and we're going to have much more accurate models to tell people what's really going on with all this stuff.
Yeah, and that's basically where we're at. So, you know, as we get better and better and better, it's just like with anything. You see, like, sports equipment, for example. Remember your first pair of cleats?
I do.
And they were pretty god-awful.
Yeah.
Yeah.
Basically wearing a boot, but with spikes at the end of it.
Yeah. I might as well have just driven nails through my pair of sneakers, you know? So my whole thing is, as we get a little bit more intelligent, understand how these relationships work a little bit better, we're going to be able to do better climate models. So that's why the 1970s models and people who climate change deny us always bring those up, is because they're not wholly accurate. Because, like I said, you don't have supercomputers. You have a bunch of people in a room who are being paid not so much money.
Some money.
Some money. All that hush money.
Yeah. Actually, Dave, they're getting round earth money. That's what they're getting. They're getting all that round earth money.
I'm a round earth shill. That's all I got to say. But, you know, my whole thing... Still waiting
for those checks to come in. Still waiting for them to come in.
Why is Big Pharma going to pay me off for the cure? Like, apparently I know the cure for cancer, but I don't want to share it with anybody because, you know, I don't want anybody to be cured of cancer. It kills me. So let's talk about some of the different types of models. I don't know why this is not working. I'm so upset right now. But, so there's the zero dimension
The
model.
good news is that we will post the slides, and we do have all the presentation and all the information already there. It just keeps going in and out, though. It's annoying.
It's because of lamp. They want to save money on the lamp.
Do you love lamp, Dave?
I love lamp. Brett, do you really love lamp? So what a zero dimensional model is, it's just they look at, there's actually a formula. It's a little bit more complex than what I'm used to because I'm a biologist, not a physicist. But basically what it's saying is that they take into account energy outgoing from the Earth, basically anything that's like actually moving off or radiating from the Earth, the solar constant, which can change because, we have solar flares and different like outputs of the sun, and it's actually on a cycle. We have actually predicted said cycle accurately for the next thousands of years.
Nice.
Thousand of years. Earth's albedo. It's kind of like libido. So it's basically like the tilt of the Earth. The radius, pi. I don't think anybody questions pi.
No. No question pi.
But pi, is questionable. Not everything's questionable. Fake news. The Stefan Boltzmann constant, which I'm sorry, it's a model fictive temperature, sometimes called the equilibrium temperature of the Earth, and the effective emissivity of the Earth. Basically, how much radiation will be let off. And basically what that is like your bare bones model. It's not really what's used when people talk about climate change, but all those zero-dimensional models indicate that we are going towards a warmer planet. The radiative connective model, or convective model, is just using the solar constant and average Earth temperature, and it basically it's adding a different level of complexity to the model. So then you move on, and you get a higher dimensional models, such as the Earth systems model of intermediate complexity. Now, this is a quote from Wikipedia, so forgive me. Depending on the nature of questions asked and the pertinent timescales, there are on the one extreme conceptual, more inductive models, and the other extreme general circulation models operating at the highest spatial and temporal resolution currently feasible. Basically, there's an intermediate model between the zero dimension, which just looks at one little cube, like we said previously, or of the globe. That's very, very basic. And then you can get into these global general circulation models that are what basically people talk about in, when they're listing climate models.
Yeah.
So these are all different countries, different general circulation models. So they take into account winds, currents, wind currents, sea currents, land temperature fluctuations, ice and sea constriction and restriction. Earth will cool itself in some way. Yeah, that we can go into an ice age, or we can actually go in the opposite direction and go the way of Venus, because that's generally the consensus that Venus actually threw up too much CO2 in the atmosphere, held in too much temperature, too much energy from the sun because it's closer, and did it on a quicker scale. Than
I don't want to move to a Venus type atmosphere.
Yeah, I don't either.
But I do want to very quickly say shout out to Wikipedia.
Yeah, shout out to Wikipedia.
Yeah.
And actually, if you look at the sources that they're actually citing, a lot of them are Nature articles.
Well, dude,
Nature and
Wikipedia is completely different from even what it was 3 years ago. It's like a legitimate resource where you can go, and if you don't believe it, just go into the references and click.
Yeah,
the
check the references out.
Yeah, like that's. I always get upset when people shit on Wikipedia because, no, I have quoted Wikipedia on papers, and I have gone in and tried to edit Wikipedia for specific reasons, and it's a very tough process. It's not just.
It goes through actually a panel now of actually 5 different people who list their job titles, and I don't know how much background checking they do, but it's actually somebody that's.
Well, it's all contributors. It's all contributors and moderators, and it's all kind of
actually
you couldn't go on Conor McGregor's Wikipedia page right now and just put anything, right? You couldn't.
You can't go to Rocky. You can't go to Sylvester Stallone's Wikipedia page and say that he ended the Cold War.
No, you can't.
Darn.
I mean, you can.
You used to be able to.
It won't go past the review process. So
that's the whole thing. And then, actually, a little side note on Wikipedia is that a lot of people, when it first came out, thought it was going to fail because there's no incentive, there's no financial incentive for people to go on and edit it and actually keep it up to date and blah blah blah.
People have lots of weird interests, man.
Socialism.
Yeah.
That's socialism right there. That's not capitalism. That's socialism. Wikipedia is 100%.
It's crowdsourcing. It's all, hey, contribute if you want to, and let's try and get this where we want it to be.
Let's make the world a little bit better.
Yeah.
Yeah.
There's plenty of money to be made in the world, Dave. Plenty of money to be made. You can make it the right way.
Bingo.
That's my model. I'm on advertising. So
God, I love you. That's why we're besties. So let's talk about general circulation models. General circulation models discretize the equations for fluid motion and energy transfer and integrate these over time. Unlike simpler models, GCMs, or general circulation models, divide the atmosphere and or oceans into grids of discrete cells, which represent computational units. Like we were saying, those little squares, you can be bigger, you can be smaller to make it more complex. Unlike simpler models, which make mixing assumptions, processes internal to a cell, such as convection, that occur on scales too small to be resolved directly, are parameterized at the cell level, while other functions govern the interface between cells. So basically, you have a whole bunch of formulas for the cell and how all those cells interact with one another to give a big globalized
processes
picture.
and procedures. This is how shit works.
Yeah, bingo. It's like, say, marketing. You have a product station, you have accounts receivable, accounts payable. Okay, just because marketing is operating under certain parameters does not mean that it's not going to affect accounts payable or accounts receivable or or the manufacturing base.
But they still each have their own processes, but they're all related at the same time.
And we can still predict how that company's going to do over the
next
next
flow, baby. The stock market.
5-10 years. So we can predict models for the stock market, and there are some that are wrong, but there's a lot that are right. And there's a reason why certain people get richer and richer and richer. And companies like General Electric always do better. While some other companies like Yahoo did really great for a little while. And now they're just kind of like, the source for porn emails.
Pretty sure they got bought by Verizon.
Did they?
Yeah.
Interesting.
Yeah, that's a whole different story.
I like the Family Guy skit where they're like, it's, Consuela's like, oh, no, we're going to be the source for porn emails. And that's it. Yeah, like we don't need...
I didn't find that episode.
Oh my
that's
God,
hilarious.
it's so good. It's from the new season. So,
I can find that.
All right. So, what is global circulation model? What actually is it? And when they say it, it's a computer program.
Nice.
You know what I mean? Like,
like
you plug... Yeah, I like computers.
Yeah.
I like Twitters and the Facebooks and the apps. The app, as my cousin Matt would say, the application store. They have numerous things that you would never even know you need.
Yeah.
So like Venmo, that's a computer program, but you trust that it's going to give your money to somebody and then get it into your bank account.
Or just how about Uber and Lyft? You
Yeah.
trust that some random person is going to pick you up and take you from A to B.
I'm a little mad at Lyft right now because they charged me $90 for a ride, but they did refund me. I give the credit. The guy just
I was about to say, we'll have to put together a social media campaign.
4 hours. He was driving from here to like Trenton.
Why didn't you just cancel your ride?
All right. I was drunk at 9. I was having a little fun with the fiance, and then I fell asleep. And then I noticed, because I go through my bank app every week, Friday or Saturday, and I go, okay, what did I purchase this week? Wow, I shouldn't have purchased that. $89 on Lyft. Yep. Where did I go? So then I went to Lyft and the whole 9 yards. So they resolved it. But
good man.
You trust that these things are going to work. So why would you trust that the application you're using is going to work? Why would you trust that your car in the morning is going to work? Why are you going to trust that, maybe I should get an oil change every 3,000 miles?
You trust the opinion of someone else who has more knowledge about the subject than you.
Yes.
Basically how we all kind of go about our day.
How society works.
Yeah. If you question how you even understand, if we question what we understand are the facts, then we can never get to an actual understanding.
Yes.
Like if people can't even agree, look, these are the facts, then nothing's ever going to come from this situation, which is why a lot of these conversations are so frustrating. It's like we can't even agree on what we're looking at.
And that's the thing, and then politicians, and that's the thing. Scientists say, okay, we have a problem. Politicians are like, we need to debate if we have a problem. I'm like, no, that's not what reality is.
I think you have to look at what's the worst possible outcome for you being negligent. The worst possible outcome is, I don't know, hundreds of millions of people suffering from flooding and from other natural disasters because you sat on your ass and you decided to just do nothing.
Exactly.
Sit on your cash.
And that's the other thing is that I truly believe that we don't have actual debates about policy issues is because money in politics. And that's why I'm a big fan of wolf-pack.com.
Yep.
Big shout out there. And Justice Democrats, because I don't think that we should start a new party. I really think that we should do an internal takeover of the Democratic Party because they've become so beholden to their own donors that they don't actually fight for, strongly fight against, people who deny climate change, the people that deny science. And I'm not going to rub Republicans because, they're terrible too. And Democrats, they're all terrible.
They're all equally terrible.
But the Democratic Party used to be the ones that fought for science, fought for workers' rights, fought for this.
Well,
but they've gotten bought out as well too.
Not you, because you're a scientist and you don't believe in a 40-hour work week, but me and the rest of us have a 40-hour work week thanks to labor unions.
Yeah.
Back in the 1940s.
But unions are terrible.
I don't know if you took that class at Temple. It was Race and Society in America. One of the best classes I've ever taken in my entire life. I still remember a lot of the things I've learned in that class, like weekends, paternity leave, which is garbage, but maternity leave, like all these things came about.
I get paternity leave.
I mean, my company's great. I get 3 months.
I get just 6 weeks.
Do whatever I want.
But hey, as a PhD student, it's pretty good. I'm still getting 6 weeks of paternity leave.
Yeah,
and that's great.
Pretty good.
And I can take that non-consecutively.
Mm-hmm.
Yeah,
that's the real move.
That's a real move. Take 2 weeks. Rosa takes 2 weeks. I take 2 weeks.
Come back and forth. That's good. Exactly. That's cool.
But, all right. Now I'm going to list some limitations because as a scientist, there are limitations to our understanding and how these models actually work. I'm actually going to directly quote, I actually want to get the website correct, so I'm going to flash ahead, weather.missouri.edu. So it's the University of Missouri, actually their cumulative reports on climate change models. So following points summarize the main findings of this chapter. It's a whole book, actually. Properties inherent in models make dynamic predictability impossible. Without dynamic predictability, other techniques must be used to simulate climate. Such techniques introduce biases of varying magnitude in model projections. So basically it's saying that, like the cloud example, we don't know how cloud change and temperature change affects cloud stability and all that. So we have to make an assumption about, okay, it does this amount of damage or it does this amount of warming.
Let's call it X.
Yes.
Let's call it Y.
Pretty much exactly what they do.
Yeah.
To have any validity in terms of future projections, global circulation models must incorporate not only the many physical processes involved in determining climate, but also important chemical and biological processes that influence climate over long periods of time. So basically saying that there's a lot of wildfires one year, there's a lot of vegetative growth, there's a lot of this, there's a lot of that. There's actually a big green boom right now in terms of the amount of plants that are growing because of the CO2 enrichment of the atmosphere. That's not saying that, green plants and trees are going to be able to compensate for our increase of CO2. Maybe over millions and millions of years it might be able to, and we're going to change the world and direct evolution a certain way, but it's going to kill the way that we live currently and how we grow crops currently.
Well, Dave, that would require us to basically plant a new forest the size of New York, every month for the next 10 years.
And it's not going to happen. So, and there's limitations in computing power. So like we said, as we get better computers, the 1970s models weren't as accurate as they are currently. But we still take into consideration the underlying math that is involved in those. But they had to take shortcuts to make the climate models that they have. The magnitude of the range of projected responses to a doubling of atmospheric CO2 by itself established that large errors and limitations in the models remain to be corrected. Meaning we didn't account for how much CO2 we were actually going to pump out in the past 50 years.
Yeah.
That makes a big deal.
I don't think anyone really could, to be fair. It's probably the tail end of a bell curve,
Bingo. And many of these models fail to properly account for multiplier effects. So if X happens and Y happens and Z happens, it's not X plus Y plus Z. It's X times Y times Z.
Sure.
So 2 plus 5 is 12.
Yeah.
But 2 times 5, 10 times 5 is 50.
Yeah.
There's a significant difference between 12 and 50. So that's another thing. And this is going in favor of climate models. Oh, so you didn't predict it correctly that it increased at 2 degrees. You only said that it was going to go up by 1.5. How is that an argument against what we're saying?
Yeah.
And many climate change deniers will use that and say, oh, well, you only predicted 1.5, but they were wrong. Well, it was 2 degrees.
Yeah. Well, see, that's where someone who understands the nature of data and someone who understands the nature of the scientific process could actually go in and say, oh, why was this only 1.5 instead of 3? Oh, it's because of this. Because X times Y equals Z in this case. All right, now I understand why it was only 1.5 instead of 3.
But
instead of, nope, that fact's wrong.
Somebody
Fake
who doesn't
news.
understand.
Fake news.
Exactly. Somebody who doesn't understand math
Yeah.
or has just a cursory understanding of like addition,
Yeah.
it's going to go, oh, well, multiplier effect. Oh, well, that's 5 plus 5 plus 5 is 15.
Yeah.
Not 5 times 5 times 5 is 125.
Yeah.
Or 75, rather. Goddamn, sorry.
It's all good. It's all good.
Math. It's a Monday. Sorry. But, my whole thing is that there's proof in the observable world. There was a guy that said, oh, well, there was a dip here, just a little dip here, so the world's not warming as quickly. And that was on the Senate floor, where the scientist goes, wait. What you're looking at is a scale like this.
Mm-hmm.
And, yeah, it went down in 2 years from a high of like 3 to 2.2 or 1.5, which is still higher than it was at this point in time that you're not showing on your graph.
Mm-hmm.
If you expand it out, there's an increase in temperature.
Yeah.
And that's the whole thing. There's a lot of climate change deniers that will go like, oh, well, between the years of 2004 and 2006, there was a slight dip in the amount of temperature overall. Yes, in comparison to maybe like 2004 to 5 or 6, yeah, there's a slight dip, but compared to 2003, it's still up by a net gain of 1.5.
Yeah.
So people manipulate data all the time at a political level to get their point across to take care of their donors.
Yep.
Let's leave it at that. But there's proof in the observable world, and this isn't the United States. I just want to let that be known. The chart that I'm showing here is from Japan.
Nice.
The Japanese want to ruin American business.
Well,
so,
Dave, climate change is a hoax conducted by the Chinese.
Oh, I know, but the Japanese are in on it too.
Japanese are in on it too?
Oh, jeez. Wow, all these people are in on this climate change thing, and I'm waiting for my check.
Still waiting for that check.
Where's my check? Guys, where's my check? So my last thing and the main thing that I want to bring up is the economic cost that climate change is actually going to have on the world. And, a lot of people go, oh, well, it's going to cost us so much money to, do these new initiatives. And, we got to make cars that are, more fuel efficient. And, we got to make companies not use so much electric and blah, blah, blah. Companies save money by switching over to a green technology, mm-hmm. such as solar panels. There's actually a study, and a speaker came here. Forgive me, I'm blanking on the name, that looked at Merck's use of water,
yep.
Just water, and how they recycled their own water and used that recycled water to do their experiments and actually make big manufacturing of antibodies, drugs, mm-hmm. different things like that. And they saved billions of dollars over the course of 5 years because they're starting to recycle. They're starting to look at like, oh, wow, maybe we shouldn't just exploit all the resources around us and actually kind of think like, wow, maybe we can save a few bucks.
In 10 years, it's all going to be a sunk cost anyways. So, and in 10 years, hopefully it's regulated, and hopefully we're making everyone move in this direction so that, they don't hold the rest of us back. Because, I mean, dude, this is maybe not the best example here, but like you look at Bethlehem Steel. Just look at Bethlehem Steel.
Didn't reinvest in new technology.
Didn't reinvest in new technology. They got, it was also the 60s and 70s, and it got a lot cheaper to import steel from Japan.
Well, that's because Japan invests in what's called oxygen firing or electric firing. We used coal and natural gas.
Sure.
Japan used pure oxygen burning furnaces to actually make steel, and it made it stronger, it made it cheaper, and everything else. Bethlehem Steel in 1980 could have invested a little bit of money and made oxygen burning furnaces, but they're like, no, we're still making it cheaper.
Well, they also probably had a lot of contracts and agreements with a lot of the coal mines.
I get that.
Anyway, but the point is that their entire business model could have been different.
And capitalism is predicated upon, what's the best, newest, innovative thing. Mm-hmm. And if we're subsidizing these natural gas and oil companies to just keep producing the same old tried and trivial thing, mm-hmm. it's going to make business worse off in 30, 40 years. I don't think they need any
subsidies at this point. I feel like the oil and gas industry is pretty well established.
And a lot of people argue like, oh, why should we give subsidies to green technologies and green firms? Did you know in the 1920s and 1930s, the U.S. government, federal government, gave subsidies to oil and natural gas facilities so that they can build their businesses so that we can be an economic superpower? Huh. Did you know that?
Dave, let me ask you something. How many blacksmiths do you know?
Actually, I know one. Because
right. Well,
I know one. But compared to, say, 200 years ago.
How many glass blowers, how many barrel makers, right? Look,
they're hobbyists.
I get it.
They're hobbyists.
I'm definitely not saying that people in this industry.
And most glass blowers are making bongs, so let's be honest.
Most people in these industries, right? Of course, they're worried about the jobs, they're worried about the families, they're worried about things they have to pay for. We should work on how do we get them into the newest, latest industry, not propping up old, failed industries that are just going to hang around forever, that are costing us money and are really bad for the environment.
Why can't we train old coal miners
to
work on solar panels, to work on
and look, maybe
windows.
Not everyone has the skill set, but some of them will. And some of them may be able to go into management or might do something else. But look, you can't prop up I wouldn't say failing at this point, but like these industries that are just they're not going to be beneficial. They're not beneficial now.
Exactly. And that's the whole thing is that, people are lazy.
Yeah.
People want to pass their jobs on from son to father to son, mom to daughter, father to now daughter, or mom to son. We're very open-minded.
Open-minded here.
Very open-minded here. But like the whole thing is that we should offer like NAFTA. The whole thing with NAFTA was that our manufacturing base went to certain other countries for products that, like upholstery for chairs or curtains or clothes, textiles. They went to different areas because it was cheaper to pay. But we should have offered programs to those people to switch jobs to innovative jobs, thinking jobs. But a lot of people don't want thinking jobs. And that's the whole thing is that you see the economic upturn in this country since the Great Recession is that a lot of the blue states that have an emphasis on thinking jobs, like innovative jobs that you can't just necessarily go to a factory, take one thing, stick it into another, and then pass it down to the next guy. It's actually a job predicated upon being a lawyer, being a doctor, being a scientist, being a marketer, jobs that actually require you to think that can't be computerized, that can't be automated. And a lot of that's the actual big issue in this country is that it's not jobs that are being shipped overseas. It's that jobs are being automated.
Yeah.
It's 100% automation. It's to the point where I guarantee you in 20 years, you won't have an accountant. There won't be accountants.
There'll be
one guy that oversees the computer programs that do all the bookkeeping for a company.
So I work with some clients in the financial services industry, and automation is basically like your climate change discussion. Like there's just so many people like, I'm not gonna have a job, blah, 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 blah. And a lot of them believe that look, you're never gonna take that personal touch, right?
But
you're always gonna have a tax guy. You don't want some computer doing your taxes. Yeah,
somebody said that about the people at Wawa who used to take your order for your hoagie.
Yeah.
Now you touch a couple screens and touch buttons and done.
There's gonna be an element of human interaction just because you want to have someone review it. Like there's always going to be an element of some type of manual review when it comes to certain things. But yeah, like 90 to 99% of it's going to be automated.
Yeah, look at like Ford, Chevy, General Motors. The whole thing is that you don't really see a guy using putting a tire onto a car anymore. Robot sticks it in.
Yep. He just controls the robot.
And he literally fixes the robot.
Yeah.
That's what we need to train our people to do. And honestly, we're hitting a point where, there's a theory out there where we're actually not going to have people to do that anymore. Like we're going to have people that just run equipment, and you're going to have 80% unemployment because there's nothing for people to do.
Yeah.
Like we've automated everything, and we can get into semantics and we can get into like the evolution of capitalism and where it needs to go and blah, blah, blah. And we'll do that in a future episode. But it really comes down to the fact that if you don't trust the expertise of the field or what's going to happen in the future, you're going to be left behind. Mm-hmm. And, not subsidizing green energy and not subsidizing, innovative techniques to combat these things, you're going to be left behind. Period. You're going to be left behind. And, I think that's a good enough spot as any to leave off. But do you have anything else that you think is relevant to the general discussion tonight?
No, just whenever we can figure out, like, what dragon fire is made out of, that's what we really need to do.
Yeah.
Because, like, you got regular dragons, you got ice dragons now. Is it real fire? What kind of fire is it?
You know what I really...
Total spoilers, by the way.
Yeah. You know what I really like?
But I figure, like, look, you're 45 minutes in at this point. Like,
yeah, nobody's watching. So my whole thing is, I loved all these arguments. Like, there was a thing on Barstool Sports or whatever that a buddy of mine on Facebook shared. It's like, You're mad that the Night King threw a javelin and killed a dragon because, he's not a 10,000-year-old entity that's with magical powers. Mm-hmm. Dude, really? That's what you're mad about? Like, come on. He threw the freaking javelin, killed the dragon, and like, oh, he's the world's best javelin thrower?
He might be. He might be.
He might be.
You don't know that.
He's been around for 10,000 years. Imagine the things that you'd be great at if you had 10,000 years to practice.
That's very true. I mean, he's real bored up there. There's nothing else to do.
He's magical.
Just throwing javelins, hitting dudes all the time.
Fake creature. That's you're getting like the Night King himself. You're not mad about that.
No, not a fake. Okay, so not a fake creature, right? I'm not even mad at the javelin throw. What I'm mad about is the fact that they're miles north of the wall, and they send Gendry running, and he makes it to the wall.
Okay,
and then they send the Ravens, the Dragonstone, and then she's like, "Oh, time to go!" And then she wears a Thundercats outfit, flies north. I mean,
all I'm saying
is this in a day? Is this a week? How long are they?
All I'm saying is, like, they have to, for production value, just get through it.
They gotta get through shit. I get it. But at least they ended the season real well.
I do want to say one thing. Rick and Morty season 3 has been awesome. Yes.
I've heard. I also heard Logic was on an episode, and I love Logic.
Yeah,
one of my favorite rappers.
They actually named it, like, he gave his real name in the credits, and I was like, hey, I know that.
That's what's up.
Yeah, in two episodes ago, they ended it where Rick, spoiler alert,
I did watch.
Completely got blackout drunk, and like basically the Guardians of the Galaxy equivalent for the Rick and Morty universes is like, I kind of like killed everybody off, and I'm the shit. It's just like, and then he had all of his friends come and had a party.
I did watch the first episode, so I'm slowly getting there. I got
love that.
I got the Defenders to get through. You should also check out Ozark's, another good one.
I heard that was good. Yeah. But and then I've just actually started Ray Donovan.
Ooh.
It's on Showtime, and it's about this guy who like cleans up all the messes for Hollywood elites. So
sure.
He's like a real thug. It's the guy who plays Sabretooth in X-Men.
Oh, Cotton.
Yeah.
Cotton from Scream.
Yeah. All right, everybody. So we're gonna end there because we're getting a little off topic
now.
But whatever. So we're gonna take next weekend off because it's Labor Day, and thank you, unions. Appreciate that.
Yep.
And then September 10th, I hope you're around because
I'll be around.
We're going to get real sexy, and we're going to do the science of fitness and exercise.
You good?
So we're gonna probably take our shirts off and get a little sweaty for that.
We in the building.
And then we're going to take a week off because I'm on vacation. Mm-hmm. Can't say where because Rosa doesn't know. And then we're going to do alternative medicine, not homeopathic medicine, but alternative medicine. So we'll talk about placebo effect. We'll talk about acupuncture. Mm-hmm. We'll talk about different things like that. Not to necessarily knock those alternative medicines, but to say that, hey, there are shortcomings to them. Here are why there are shortcomings to them. And this is what you should do in conjunction with alternative medicine. And then I think we should take our shirts off again for the October 1st episode because it's the juice, anabolic steroids.
That's a good one.
So we're going to talk about the biomolecular underpinnings to how anabolic steroids work, their negative consequences, their positive consequences, and different things like that. So
good season. Excited.
Yeah, and then we're going to do some other episodes about some really cool topics. I know that you picked a really nice topic out, a couple topics out.
Yeah, so. we'll have some housekeeping news in next coming weeks too. We got some internal things we're working on, but as soon as we have something we can share, we'll definitely let everyone know.
Yeah, and then maybe for next weekend, because I know I won't have the whole hosting thing go. Maybe I'll just do a solo thing about the current news.
Yeah.
Give a little commentary about
Sounds
that.
Like
all right, everybody. Thank you for joining us. I really appreciate it, and we'll see you in 2 weeks. All right. Bye-bye.